Hi, I'm Audra. We're now getting into the business of analyzing our data in this, our 7th and final podcast. In each of the test analysis podcasts, we're focusing on a single test. As with each of the other podcasts, there are two assumptions that we have to make before we move forward. First, you're already familiar with research methods. This podcast series isn't about teaching you what research methods are and how to approach research. You should already know that before you start watching them. Second, you have a data set that you're trying to work with. The series is designed so that you watch some podcast material and then try it yourself, pausing as you need to go along. So, let's move into our 7th installment in our series, Running Regressions. In this podcast, after a brief introduction to regression, we're going to get straight into the demonstration of how to run and interpret the tests. So you'll need to make sure that your data file is set up correctly, that your factor analyses are run, and that you've completed your data analysis plan identifying which tests you need to use to analyze each of your research questions or hypotheses. If you don't have all these things accomplished, go back to one of the starter podcasts 1 through 3. In addition, if you haven't run your correlations yet, you need to go back and do that. Take a look at podcast 6 on running correlations. In this one, we're going to spend a little bit more time as well establishing the background on regressions before moving into the demonstration, because it will make it easier to understand how to run and report them. Like we discussed in podcasts 3 and 6, the purpose of correlation is to identify if variables are related, but it does not identify if there is causation between independent variables and dependent variables. If we compare this to the purpose of regression, which is to investigate causal relationships between variables based in positive and negative relationships, then we see why correlation is the gateway to regression. We have to establish that a relationship exists before we can establish whether the IV caused the change in the DV or if the relationship is just coincidental. One of the key differences, though, between regression and ANOVA is that both the independent and dependent variables are scale or continuous variables. Now, as you were shown in podcast 3, if you prefer to run regression but you have categorical IVs, you simply need to dummy code them in order to make them ready to run as correlations and regressions. So here's the difference between a correlation research question and a regression research question. The key difference is the framing. The correlation is asking if there's a relationship, whereas the regression identifies whether there is a causal change. So in our BP example, we had the relationship between the stakeholders' belief that BP was committed to cleanup compared to their willingness to protest against the company. As we're running the regression, the first thing that we do is to see if there's a significant relationship between these. Let's say there was, and the correlation was a negative 0.24. So we know these two things are related. But does the belief in BP's commitment predict whether people would protest against the company? That's what we really wanted to know, and that's also why we need to run the regression. So when we run the simple regression, we find that stakeholders' evaluations of BP's commitment to clean up in the Gulf significantly influences their motivation to protest against the company. But looking at this equation, how do we know this? Well, when you're writing up your regressions, this is how you properly report them in your papers. Let's break this down so that when we get to the demonstration, it's a little easier to interpret all the numbers that we're going to be looking at. So, the T statistic in regression is the key statistic for the regression test. Anytime you see a T and this particular equation, you know that it's a regression and not a t-test. If you want to compare the two, take a look at podcast 4 on the t-tests. The next number is the number in the sample used for the test, or in this case, the degrees of freedom. You'll find this on the printouts. Next is the value of the test itself. You look to the sign to see whether the relationship, i.e. the correlation, was positive or negative. This obviously indicates a negative relationship, so as perceptions of BP's commitment to clean up the Gulf of Mexico increased, motivation to protest against the company decreased. But we already knew that direction because of the correlation itself. It was a negative correlation. Of course, this is just our p-value. It's reported the same way no matter what test we're talking about. If it's less than 0.000, it gets reported as less than. However, if it's between 0.01 and 0.05, then you would report the specific number. And as always, remember that we set our significance level at 0.05. The final number tells us exactly how much of the variance that we accounted for. If you remember from our conversation in podcast 5 on ANOVA, we can think of the dependent variable as a pie chart. What we're hoping to do with our statistical tests is account for as much of the pie chart as possible. So we convert this to a percentage, and the slice of the pie that we can account for with understanding perceptions of the company's commitment to clean up predicts 6% of the pie. So their likelihood to protest against the company. With the ANOVA, this was the partial eta squared that told us this. With regression, it's the adjusted R squared that does. What we'll find with regression is that it makes for a better test for accounting for variance in the dependent variable. It's that it's a more flexible test for including several independent variables and being able to specify exactly how much of the pie we can account for with each. Remember, the ANOVA is a bit of a blunt instrument. This is a much more fine-tuned test for understanding exactly how much of different variables account for the differences. So, if we're going to interpret these findings to make our story from the numbers, we could say something like this. One important factor that predicts whether people are motivated to protest against an organization is whether they believe that the company is committed to redressing the wrong that they have committed, in this case, in the case of this transgression. So specifically, we found that after the 2010 spill in the Gulf of Mexico, if respondents believed that BP was genuinely committed to cleanup, they were less likely to be motivated to protest. This alone accounted for 6% of their motivation to protest. So with only 6% of the variance predicted with this one variable, it and hopefully logic tell us that people act for a host of reasons. Regression lets us try to tap into as many of those as possible that both we can think of and hopefully that previous literature suggests. So it lets us specify how much of the variance is accounted by each factor. It lets us rank the factors. Obviously, this is really valuable for social science researchers and practitioners because we can better understand what kinds of message features, attitudes, and even prior behaviors we have to take into consideration if we're trying to understand or predict how people will act. This is even more important if you're trying to persuade people. So regression lets us add on multiple non-correlated or minimally correlated variables to account for more of the variance. One of the key assumptions with multiple regression, in this case multiple just meaning that we're considered multiple independent variables, is that our IVs shouldn't be related or correlated. Or at least if they are, we've tried to minimize it as much as possible and to avoid what's called multicollinearity. Now, we're not going to worry too much about multicollinearity in this podcast, but it's a topic for consideration in a more advanced discussion. Just know that it's what we're trying to minimize using multiple IVs in a multiple regression. So, if we go back to our initial question, what else could influence people's motivation to protest against a company? Perhaps we think about these variables, we think about maybe some keyed down graphics, and even one attitudinal barrier. So we might want to run a multiple regression test considering these. Don't worry, I'll show you how to do all this in the demonstration. So if we run this, we might come up with a result that gets reported and looks something like this. Notice something different here. I just said a couple of minutes ago that the test for regression was the T test. Now I'm giving you an F test. This looks more like a regression or an ANOVA than a regression, doesn't it? In fact, that's just what I use to run a multiple regression, taking account all the variables together. And just like the ANOVA that we talked about in podcast 5, this just tells us that somewhere there are significant differences. Now we have to figure out where. And this is where we go back to the T tests. Each of these will be listed in the SPSS printouts. So what can we see based on these T tests? Are all of our variables significant? Which variables are the most important in predicting people's motivations to protest against the company? Let me give you a moment to try and figure those out. Okay, so are all of our IVs significant? Yes. We just need to look at the p-tests to see that they all are. So which variables are the most important? Well, remember that our adjusted R-squared tells us how much of the dependent variable pi we can predict. So age and gender seem to have relatively small effects, with 1% and 2% respectively. Someone's political attitudes accounts for 8% of the pie. So in this case, people who are more likely to be conservative are also more likely to advocate against BP. The perceived knowledge of the company, that is how confident we are that we know a lot about a company, predicts about 13% of the motivation. And our belief in the company's commitment to clean up accounts for about 16% of this test. So, if these were the results, overall with these 6 variables, we'd have predicted about 30% of the variance in people's motivation to protest against BP. In social science terms, that's pretty darn good. So we leave the background here, and we'll come back to our demonstration. So we have our data set open, and because we're not doing anything to our data file, we're just running the statistics. Remember, it's easier to keep the spreadsheet minimized and work directly off our output. So our output's just opened, and I've saved it as regressions, so go ahead and do that with your data now. Now, remember from our data plan that we identified research questions 3 and 4 as needing regressions. However, like I talked about in podcasts 3 and 6, in order to run our regressions, we need to run our correlations first to identify if a relationship existed between our variables. Now, we did that in our last podcast, and we found that there was a significant positive relationship between perceived knowledge and behavioral intention. So this means that we want to run a simple regression to see if there is a causal relationship. It's called a simple regression because we're just looking at a single independent variable to see if it influences our single dependent variable. So once again, we go up to Analyze, we drop down to Regression, and over to Linear. Click that open, and then we make sure that we put our variables in. Let's start with our dependent variable, which is the post-test behavioral intention. We'll scroll down and we'll find that. And then we want to move into our independent variable, post-test perceived knowledge. And you'll notice this looks a lot like our ANOVA screen, and just like our ANOVA, the less that we can enter, the better. So on this page, this is all we need to worry about for our simple regression. But let's go up to the statistics box, click on that, and with that, select R-squared change, and descriptives. Then click Continue. And we're ready to run. So don't click anything else. Just go down and click OK to run your regression. So we've come up with a lot of different boxes. Let's make our way through them. We definitely won't be looking at them in the order they're presented. The first box is just the descriptives. We won't use that for the interpretation right now, but keep track of them for reporting them later. Second, you can ignore the correlations box. We already know what the correlation is. Third, ignore this box. It's the variables entered removed. This is just SPSS showing its work. We'll skip the next one for now, because we'll be coming back to this model summary box. Since this is a simple regression with only one independent variable, we can also ignore the ANOVA box. That's only relevant if we have multiple independent variables. So our first actual stop is our coefficients box. This is the actual regression test that we'll be reporting. So let's work through this from left to right. In the left column, you'll see the constant, which for the simple regression we just ignore. So we only look at the row with our independent variable. Also, for the simple regression, skip the B, the standard error. Those get reported, but not interpreted. In the multiple regression, we also ignore the beta box, so the fifth box that has our t-test value itself will report in our equation. But as always, the real point of interest to start with is our p-value, the significance column on the far right. So, is our regression significant? Of course it is. It's very significant because it's less than 0.000. So, although we already knew that the relationship was positive, this is also indicated right here with our t-value. If the relationship had been negative, the t-value would have had a negative sign. So now that we know that our test is significant, we want to go back up to the model summary box, because this tells us how much of the dependent variable pi we can account for with our independent variable. So let's take a look at these columns as well. So this first column really just tells you that which independent variables that you have included. Because it's a simple regression, there's only one model. We ignore these next two columns because the most accurate way to determine how much of the variance we can predict is by looking at our adjusted square box. So our figure, a 0.30, is really good. This means that this variable alone accounts for or predicts 30% of the change in our dependent variable. Now, for simple regression, we can ignore the rest of these columns over here. So let's come back to the interpretation. We're accounting for 30%, but how do we tell that story? So very simply, Research question 3 asked whether people's perceived knowledge about a particular airline would influence their behavioral intentions, as in to buy a ticket or recommend the airline, towards the airline after the introduction of a crisis. This result shows that if people believe that they know a lot about an airline, then they're significantly more likely to make a purchase or recommend the airline even after a crisis emerges. Likewise, the other way to look at this would be to say that if people feel like they know less about an airline after a crisis emerges, like the crisis has revealed some kind of new information, then they're also less likely to make purchases from the airline. In this case, the 30% adjusted R-squared value tells us this is an incredibly important factor to consider in the case of the emergence of a crisis in the airline industry. See, it's still about telling the story that emerges from the numbers themselves. Okay, so that was a simple regression. Let's go for a multiple regression in order to answer research question 4. Here, though, we have some decisions to make before we proceed. Remember that the goal of data analysis, especially with regression, is to get to the simplest answer that accounts for the majority of the variance without introducing intolerable levels of error into your test. Like I said in the background on regression, the first hurdle to clear is that there would be a significant relationship between your independent variables and your dependent variable. In this research question, we're interested in some of the factors that might influence the negative word of mouth or negative WOM. That is, people's likelihood to speak negatively about an organization after the emergence of a crisis. Based on the literature, we believe that the perceptions of a crisis response as being culturally appropriate or inappropriate, evaluations of the airline's reputation, whether people attributed the blame about the crisis to the airline, and the evaluation of the airline's competence in health and safety were all likely to influence negative WOM. So based on our correlations, the perceptions of the airline's competence were not particularly significantly related to negative word of mouth. So the first decision is that we should exclude it from our multiple regression. In our results section, we would simply indicate that the variable was excluded from the multiple regression model because it was not significantly correlated. So what about the others? They're clearly significantly correlated, but remember, I also said we didn't really want the IVs to be correlated to each other, because then it's difficult for the regression to separate which variables provide how much explanation for the dependent variable. In other words, the lines in our pie graph get a little blurry and we may not be sure of where one concept's influence ends and another begins. This is our multicollinearity problem. Again, for this podcast, we're not going to get too technical with this issue, but it's something to be aware of. So let's look at our independent variable correlations. The good news is for us that this airline competence variable was the biggest problem. However, we can see some significant correlations between our other three variables. So we have to make the decision as to whether we should include them in the multiple regression or not. Blame attribution and negative cultural appropriateness of the response, or the culturally inappropriateness of the response, are not significantly correlated, so we're good there. However, reputation is correlated with both cultural appropriateness as well as blame attribution. But if we think about it, reputation being connected with whether something is culturally appropriate and whether we attribute blame makes logical sense. But what do we do about this? We know we'll add a bit of fuzziness and maybe some error into our test if we keep all three in. However, we have a strong literature-based reason for including all three, and their correlations, while they're significant, aren't really all that large. So the decision we can make is that it's reasonable to keep them in. It's equally valid to take one of them out if you didn't have a strong literature-based reason for including it. So for the sake of our demonstration, and because the literature on the impact of reputation, we're going to leave all three in. So let's go about running our multiple regression. We're going to start the same way. We're going to go to analyze, we're going to go down to regression, and over to linear. So we're going to take out our dependent variable, and we're going to put our new one in, the post-test word of mouth. And we're using negative word of mouth in this case. Now we're going to be putting our independent variables in a bit differently. We're going to take that one out. First, we're getting rid of that one. So in order to see exactly how much each of our variables, IVs, influence our DV, we need to put them in separate blocks. The decision about what order to go is up to you, but you need to be able to describe what you put in which order and why. So, for example, if you had demographic variables that you would want to control for, like in ANOVA, but that you weren't really interested in testing individually, those would always go in the first block. Now, we don't have any demographics to include based on previous research, and our research question doesn't ask about those, so we're not going to be including any of those in our test. But if there are some variables like reputation that are addressed in the literature as being very important or very commonly tested, they would go in first. Because if you're adding new variables to research, or you're asking if there are new relationships, you need to see if they have any impact over and above what we'd typically expect to see influencing our DVs. So we're going to start with reputation because research on crises suggests that reputation is one of the most important predictors. So we begin and we move that over. However, there isn't as much research in the perceptions of crisis responses as being culturally appropriate, so we're really curious to see if there's a meaningful impact. So we would put that in second, or that we'll put that in third. Rewind. The second most important factor, according to the research, is actually blame attribution. I was forgetting that one for a moment. So we're going to add blame attribution in next because the literature talks about it as being also an important predictor. So we come up here and we find our blame attribution. Now, instead of putting this all in the same block, what we do is we click Next. Then we take our post-test blame attribution and we put it in. And now for our third one, like I was just saying, we don't really know a lot about the cultural appropriateness. This is kind of a new variable. And whether respondents perceiving whether an organization's response to a crisis was actually appropriate for their culture isn't something that's been tested before. So we're going to put that in third because we want to see over and above the two variables that are often considered reputation and blame attribution, we want to see if this new variable, cultural appropriateness. Now, since we use negative word of mouth, we're also going to use negative cultural appropriateness or something being inappropriate, and we're going to put that over. So we've put those three variables in using our next function, so they're in three separate blocks. Now, because the regression was already set up for our last test, we don't need to change anything, but just as a reminder, the only thing you change is in statistics, you want to make sure that R-squared change and descriptives are checked. Click Continue, and click OK. And we have our multiple regression. So you're going to see the same boxes as we had before, but now there's just a little bit more content in them. This time, however, instead of beginning with our coefficients box, because this is a multiple regression, we begin with our ANOVA box. Since we're asking whether three different variables influence our dependent variable, as we start with the ANOVA box, when you look at it, you're going to see three different models. Now again, the model is just SPS's way of telling you which variables it's considering in each of the tests. So if you need to be reminded as to which variables you put in what order, it tells you that right down here. So Model 1 is just reputation. Model 2 takes into account reputation and also blame attribution, and then Model 3, reputation, blame attribution, and cultural inappropriateness. So, this lets us know how much each one adds or contributes individually. So, from the results of the F-test, which you read just like you would from our ANOVA discussion in Podcast 5, you can take a look at the p-value and see that all three are significant. That's great news. Now, you'll need to keep track of these numbers because you're going to report them in your table later, and you will definitely be using a table for reporting a multiple regression. So now let's see just how much each is contributing. So this is where we go back up to our model summary, and we look at our adjusted R squared for each one. So as we look at each of these boxes, we can see different numbers. Reputation itself only accounts for about 1% of the change. Reputation plus blame attribution, about 8%. And then when we add in whether the crisis response message from BP was viewed as culturally inappropriate or not, that accounts for a total of about 22% of the change. Now, this doesn't mean that blame attribution contributed 8% and cultural appropriateness 22%. These are cumulative totals. Now, we could do the subtraction on our own to pinpoint exactly how much each of our IVs contributed. However, I promised you at the outset of this series that there was no math required, and I'm going to stick to that promise. So, if you look at, I'm going to make this a little bit bigger. If you go over and you look at the 6th column, you get the R squared change. This pinpoints exactly how much of the change in the dependent variable that each of the IVs contribute. So we can also see if these changes themselves are significant by looking at the very last column in the table, the significant F change. This tells you whether the change for each model, that is adding each of our independent variables, made a significant contribution to the amount of variance you can predict. And, as you can see with the p-values, the answer is yes. But our work isn't quite finished yet before we tell our story. Now we need to go back down to the coefficients table, where the regression tests actually are. The most important of these models, and the one that tells you whether you have 3 variables that make a meaningful contribution, even if the adjusted R squared is small, is to look at the significance test for the last model that takes into account all 3. So if reputation, because it only accounted for about 1%, wasn't making a meaningful contribution, its significance wouldn't be under 0.05. However, the relative size of the t-values does tell you which ones are making the most contribution. Now, this aligns obviously with our adjusted R squared scores. We know that reputation accounted for the least, blame for about 8%, and cultural inappropriateness by itself about 14%. So, in our final model is where you can say, well, all 3 of our variables, or 2 of the 3 variables, contributed meaningfully to our overall adjusted R squared. So, how do we tell the story of this particular test? It would go something like this. In order to better understand what prompts people to speak negatively about an organization in crisis, we asked whether consumers' perception of the airline's reputation after the crisis onset, attribution of the blame for the crisis, and the perception of the airline's response as being culturally inappropriate influenced their negative word of mouth. These data clearly demonstrate that a combination of high reputation with a high attribution of blame and belief that the response to the crisis was culturally inappropriate all increase the likelihood that people will speak negatively about the airline. These factors alone account for 22% of the variance. So, that's how we would explain it in the results section. One of the implications for the discussion section, to bring it all together, that I might think about is this puzzling relationship between a really good reputation and high blame attribution and culturally inappropriate response, leading to more trash talk about the airline after a crisis. The second two make a lot of sense. However, how do you account for the high reputation? So one of the things I might jot down in my notes in my Word file as I'm going through and summarizing the results and doing my tables is that maybe this could be a violation of someone's expectations. So amongst people who really believed in the airline, when they screw up, they fumble the response, people are more likely to talk negatively about the company. So I might make a note to myself to take a look at the expectancy violation literature and see if that can help explain it in the discussion. So as you're going through your results, if you're constantly thinking about the story and how the story all pieces together, it's about reasoning from what you have. That's why in the research process, you begin with the literature review. You need to understand the state of the art as it is. And then when you find research that supports or adds to or even sometimes runs counter to it, you can explain it. But it's all about telling a story. So we've come through our regression analysis without having to do any math. But now we have to report our data. So how do you write all of this up? Let's take a look. So in the case of regressions, the basic divide in how you report your data is whether it's a simple regression or a multiple regression. In the case of a simple regression, you report your correlations as I demonstrated in podcast 6, and then you would report whether it was an insignificant or significant result using this kind of a standard sentence and filling in your information. When they're significant, you report the t-value, the degrees of freedom, the p-value, and the adjusted r-squared, which we discussed earlier in terms of its format in the background on regressions. In the case of multiple regression, you do basically the same thing, but in this case, like we discussed in the background, you would report the f-test using the very last model. So, our research questions 3 and 4 were our regression research questions. So let's take a look at how the numbers plug in to our demonstration sentences. So for research question 3, in your results section, you would start with something like, a simple regression was run evaluating the influence of perceived knowledge on behavioral intention towards the airline. It was significant with a t of 2,110 degrees of freedom, 30.33, and a p of less than 0.00, and adjusted r-squared of 0.30. For your research question 4, in your results, you would say something like, a multiple regression was run evaluating the influence of reputation, blame attribution, and cultural inappropriateness of crisis response on negative word of mouth. It was significant, and the equation. However, there's always going to be a table for your multiple regression. So let's take a look at how to fill in a table for your multiple regression. There are a lot of different types of tables. However, I like this one because it includes all of the information that someone might be interested in. So let's go through where we get all the numbers. You'll notice that at the top, this is broken down by models 1 through 3, going across the columns. Now, if you only had 2 groups, you just delete model 3. If you have more than 3 groups, you add in others. You get the point. You may also have multiple independent variables within each model. So your IVs get listed individually in the first column along with the intercept. This is labeled constant in the SPSS printout. So, we're going to start out with the coefficients for the regression because those go in the top half of our model. So let's find our numbers. So we begin with our beta, and you notice that we report the constant for each of the models. So our beta in each of our models, it doesn't have one, so you leave that simply blank. But then you report the standard error. So the 0.13 corresponds with the 0.13. Then you also report the t-value, and we go from 23.35, we translate that over here. Now we also can use the asterisk system, just like we did for the correlations. In this case, the note at the bottom, 1 asterisk, is between 0.02 and 0.05. 2 asterisks are really basically the 0.01 level. 3 is a way of kind of bragging and saying that you're at the 0.000 level of significance. It's a nice thing to include. So you indicate the p-value in the table just with the asterisks, and you would put a note at the bottom to help interpret what the asterisks mean. So when we finish up Model 1, we can see that our beta for Model 1 is 0.07, and the standard error was 0.03, with our t-value of 3.17, and our t-value. We do the same thing for each of our independent variables and each of our models. So this bit gets a lot larger as you go across, more numbers to fill in. It's a bit tedious, it'll take you some time, but this communicates all the key information that people would want to see. Now, in the bottom half, we're not done yet, in the bottom half comes our top 2 boxes, the ANOVA and our model summary. So the F is the F test for each of the models. So we've picked a column from each of our models and keep it consistent for aesthetic purposes. And so we see that our 10.06 comes over here to 10.06. Our degrees of freedom, just like in ANOVA, is the within subjects and the error. So 1 and 1940. Then we come up to our R-square. We report that in the regression table. So that was 0.01, as is our adjusted R-squared. And it's a small abbreviation. Then we also include our R-squared change and indicate if that was significant using the same asterisk system that we did before. We put in our degrees of freedom once again for the change statistics. So we fill in all of our information, and so at a glance, a reader who is familiar with regressions will have all the information they might want in order to help interpret the data for themselves, so that as they're reading your write-up, they can look and see. So like SPSS showed all of its work, with multiple regression, you'd like to show your work, except we do it in tables. And that is all for our last podcast. So we've gone through each of our topics, and hopefully you have a little bit of a better idea on how to run and interpret the basic statistics.